Let me introduce myself. My name is Nicolas de Horta. I'm part of the research and development studio at OrangeLoops. And today we're tackling a pretty hot topic, this conversational agents. Uh, we're talking about the future of AI-powered chatbots, and we may start, right? Okay. So, same. We're going through some topics. First, we're going to do introduction. Then we will define what an agent is. We're understanding what a conversational agent is in particular. Then the applications we'll have for them. Why should we use an agent and what are the benefits of it? We're going through superficial explaining what a vector database or embeddings are to understand some of the features we're going to be. Then the workflow of an agent, and then a short conclusion of what we said. So we shall start. First, we're going to introduce, we know the context nowadays, all chatbots, we all went through chatbot and chat with a small bubble at the bottom right of a screen and a website, and chat with a kind of chatbot that help us like tackle some basic stuff, like asking for information or I don't know, contact info or some simple query. Those old chatbots have been for a while, and they're pretty restrictive. Like they don't seem natural. Many call them like mindless chatters. They don't have like personality or they can be crafted through a personal use case. They usually misunderstand the request entirely. They have to match words and do some stuff to understand what the user is saying, but they can't understand complex scenarios. That changed when the new era of LLMs or large language models came in. AI chatbot became really important for some companies and for almost everything. We all use ChatGPT, I expect. This is the next generation of chatbots or agents, and they're more like just chatters, right? They can focus on acting or more complex communication. They can operate through voice, through text, or even by video. There are some agents out there that are like a 3D model of, let's say, a person of a cartoon that is talking to the user. We have two internal chatbots or agents that we developed with AI that are OLivIA or Slack agent. It's meant to answer employees' queries and make it they can go through the information confluence easily. And there is MaIA, a sales representative that lives on our website and helps get in touch with users or potential clients. First, we'll define what an agent is. According to Oxford Dictionary, an agent is a person who acts on behalf of another person or group and a person or thing that takes an active role. So we here know that the agent has to act. We can define it in a more techie way. An AI agent is an autonomous entity that observes and acts upon an environment, directing its activity through achieving goals. There are two main features of an agent, the sensing and the acting. An agent can sense the environment in many ways. It hasn't, I mean, we're all used to the conversational agent, like we chat with an agent and he answers, but it can sense the environment in almost any way. It just have to receive an input of any type. I don't know, factory sensors or a thermometer or, input from a chat. And then, or fetching a database is one of the main cases. Then he acts, and its action can be like anything. It can be like lowering the temperature of a room, or just answering a message, or sending an email. So what's the difference? We're gonna call chatbot the old chatbot, an agent or conversational agent, like the new one. They both simulate a conversation. That's something they have in common. Uh, they both can be web-based or by telephone messaging apps. It's the same. I mean, the user interface is pretty the same. They have increased its usage in the last years. The chatbot or rule-based chatbot, they follow predefined rules. They try to match some keywords to a database of answers and try to let's say, understand in a more synthetical way what a user is trying to say or what the user is expecting to receive as an answer. They can handle simple queries. They can't understand or get complex situations. And they're often limited to really simple tasks. They can, they can improve the usage, but it's like adding more rules to the logic. And then we have conversational agents, then AI powered. They based its processing in natural language processing with the new era of large language models. They can learn from past interactions. You can fine-tune a model is giving it a data set and let's say making it learn about the data set and expected responses based on questions. They can handle more complex conversations. They can understand the context of the conversation and what the user is trying to say, what are using intentions. And this is really powerful. They can also have tools and interact with the environment. I mean, all chatbot can too, but the usage of that tool is limited to what the all chatbot is understanding, and it's often not correct. The application can be many. We're going to mention some. Customer support. We can have a 24/7 customer support to answer and guide clients or users. We can make it work in an e-commerce, so we can recommend things based on search. We're going to go through this recommendation thing later. On banking and finance, for line transaction and financial advice of the user and questions. Healthcare, offering medical advice, symptom checking, and scheduling for a consult. And as personal assistant, like daily task reminders, music, weather updates, or how's the traffic somewhere, among others. We're going to do the benefits of animation because we already know what agent does, but why would we need it? I mean, we already have that with the things we already know. The benefits are, let's say there are three main benefits of agents. One of them is the cost efficiency. Customer support can be costly, mainly outside office hours. You should have to have like multiple teams of people working at different time zones and time sets of the day. We don't have this here. We just have a hosted agent answering questions or guiding users through any experience. Then it's a reduction of cost around salaries, training. We can have the agent immediately ready to answer questions and not having to train let's say an employee for months or things like that. It's cheaper to have the architecture of a client and scalability than having to, let's say, go through the hiring process of our place. And then availability, that is, that we already talked about. And sales and customer engagement, we can have real-time information, we can update this information, and it's already available for the agent to based on for the responses. We can avoid long wait lines. I'm not the only one who waited for several minutes to be to ask for customer support on the telephone or chat. There's an overall improved experience, and you can craft that experience through fine tuning to make the agent to talk in any jargon or in any way or any personality that you wanted to have. And it can provide recommendation or cross-selling. Recommendation is a strong topic, so we will tackle it in a moment. But you can make the agent like offer or anything if you have an e-commerce to recommend other products based on what the user is getting and searching for. And scalability. That is not simple. Adding infrastructure is cheaper than hiring and onboarding a bunch of people. You can tackle other geographical markets. There's now a language, how do you say it? I mean, there's no problem with language because large language models usually they already can talk in other languages out of the box. Restriction, right? Thanks. Well, you can handle unexpected short-term spikes in demand. Let's say something is happening on your field that is really important. Let's say, I don't know, you're getting paid on a bank, I don't know, at the start of the month, and there's a lot of people asking questions. You can have an agent that scales automatically, and you can tackle all those queries just like it. You don't have to put more people on that section for those days. And holiday seasons, there's like the agent's never gonna ask for time off. Okay, we're gonna talk about something that we already mentioned. That is, we're not gonna have a math class here. It's a concept that is good to understand, to know what we're dealing with when we say recommendations. Okay, this is a really interesting topic, and it's used in more ways that you imagine. Vectors are they're models, as they are models that answer questions and talk to the user, like ChatGPT or, well, Claude, Gemini. They're models that are really good at understanding a concept, let's say. They depend strongly on the data set that is used for that model to understand, to train. And what it is like you get information that it can be in any shape, like text, image, video, or whatever, and you pass it through the model. That model is gonna classify that information on many dimensions, and it's gonna output a vector. A vector is just a list of numbers, and it can have a lot of dimensions. It's not like X, Y, Z, but thousands, okay? You don't have to understand that, but that's what is behind, like in backstage. We have to know three things about vectors. One is a vector captures like a concept, like semantically, of a piece of information. We can do mathematical operations with these vectors, like adding them or subtracting them, which allows us to understand what the distance is between two vectors or concepts. And two similar pieces of information are going to be close between them, okay? With this, we have, like, if we have three concepts, like king, knight, or rabbit, we can vectorize it. And we know in a database, these are going to be, king is going to be really close to knight, let's say, for the context, and rabbit has nothing to do with it. Under games, I don't know if you know Infinity Craft, but there are a lot of things that are made to play with it. You can add two vectors, or and you can get a third vector. Let's say you add king and woman, and you get queen. this works like this because the concepts are added. Okay, so what we do with this? So what is this for? There are databases that are meant to work with vectors. Okay, they can handle vectors and calculate distance in a blink of an eye. Let's say we can store information. I mean, I have a product, I vectorize it and store it in the database. Okay, I do it with every product I have, and I can add them in a database and query for them without having to match the name or the description with some word that may be misspelled or in capitals or anything. When we have a user input, let's say anything, right? You can have the user saying, okay, I want to search for shoes or anything. We can vectorize its query and compare it with every product. And we can get all the products that are closer to that, the closest, let's say 10 products, and I can recommend it to the user. This can be used in more complex ways. This is a really simple example, but let's say Netflix or recommendation about, I don't know, anything, movies or books, let's say. We can vectorize the description and we can make a user look for, or based on the history of the user, on the history of movies or books the user have read, we can recommend this to users. This is how a lot of websites work. And the workflow of an agent is, well, first, a conversational agent. First, the user inputs a message, okay? Then the agent understands the context and establishes a goal. Let's say the user says, okay, I want to know the temperature in San Francisco. Okay, the goal is get the temperature in San Francisco. Then, based on its tools, an agent have access, and we can give an agent access to tools and custom tools we want. The agent decides if a tool is needed to answer that query or to accomplish that goal. Let's say the user wants to send a mail. So we may have a tool to send a mail. If not, the model is going to say, well, as a language model, I cannot send mails, so please, I don't know, go Gmail. But if we give our model a tool and make it available to send mails, it's going to be able to do it. Or maybe retrieve information, or do RAG is retrieval augmented generation. Well, this is accomplished through vector databases too. Or schedule a meeting with a file. Well, if a tool is needed, the next thing is check if the goal can be accomplished with the actual context. Let's say I say, okay, I want to send a mail, and I wanted to say this in the body, and this is the subject. Okay, the agent's gonna say, okay, who should I send it to? And then he's gonna generate the output. He's gonna ask me who, or if it has all the information, he's gonna do it. Okay, having said, there are some frameworks, okay, to work with when we're developing an agent. Three of the most popular ones are Crew AI. It's based on Crew or team multi-agent concept. Let's say we have some different agents inside of it that they all have different tool sets and tasks. Let's say one is an expert writer and it can write like beautiful text. And then there is one that it's meant to research and have like online search tools. And there's one that is an expert engineer and is fine-tuned with a lot of formula and science facts. So they can work and interact with each other and accomplish a goal. Let's say the researchers say, okay, I found this, look at this. The engineer says, okay, now write this because this is okay. And the writer writes it. Then there's a reviewer and ask for them to modify or search again or anything like that. The final result is the agent outputs what you ask you to output. Well, and they all add towards a common goal. There's another framework called DSPY. It stands for Declarative Self-Improving Language Programs. It's a new approach. It's based on a concept called zero prompting. And it was like someone said, I don't want to write prompts anymore. A prompt is what you tell the model to do. Those are like the instructions. When you talk to ChatGPT, you say, okay, I want you to give me a list of the best places to go. That's the prompt. And when we make an agent, we have to prompt it with system instructions. Those are like, you are an agent, your mission is to understand what the user means and try to answer any user questions based on blah, blah, blah. That guy said, I don't want to do prompts anymore. I'm not a writer, I'm a programmer. So I want a framework that understands what I coded, compiles it, and makes prompts out of it. Like looking at the variable names, looking at the descriptions of variables, and the structure of the code, it tried to understand it and make auto-generate the prompts, right? It's meant to be fine-tuned because every piece, you can't modify the prompt easily. You have to fine-tune each part to make it work like you want to. And it's sometimes messy or hard to implement out of the box. Well, it provides blocks like predict, chain of thought, react, that are different behaviors that those bits can have. And then there is LangChain, a well-known one. This is the framework we went through. We're using it right now. It's an open source framework. It has a really big community, which is a really good thing because they're building a lot of integrations. They're doing a great job making it like being easy to work with any platform, actually. It's based on chaining multiple calls for large language models. Well, it provides tools, agent parsers, and other abstractions to work with. And it's really easy to access. What we said before, in DSPY, you can access to each piece of program to update it. Here is really easy to access because each bit has its own prompt. You can modify the prompt to change any behavior you're having. There's also two platforms that are from the same company. Langsmith, that allows you to monitor and test all your chats or your threads or every agent call, and it provides a really detailed information about how the run went, like how many time it spent doing each thing. And LangGraph, that is like a package to orchestrate and model the workflow. Well, and now we're going to talk about our two agents. We have some more, but these are our two internal agents. MaIA is based on LangChain. We already mentioned. It houses in AWS. It's web-based. You can meet her in our website. It understands user intentions. It tries to prevent trolling and jailbreaking. Jailbreaking is a really common thing. Users try to make the agent work in ways it shouldn't. Like if the agent has a mission and you try to make it behave in some unintended way, that is called jailbreaking. It answers with information about OrangeLoops if you're trying to research about the company or understand the user intentions of developing a project or anything related. It gathers the information and then sends a mail to sales department. You can see the user interface, the right side of the screen. And we have OLivIA. OLivIA is also hosted on AWS and uses LangChain. It's a Slack bot-based agent. employees of the company can query for different things, and it's meant to reduce the friction when looking for information related to human resources or people care. It uses RAG. We already said, like a vector database to query for information. What it does is it stores all the chunks of information from Confluence, vectorize it, and store it in a database. And when a user asks a question, it vectorizes the question and asks for the most similar information and use it to answer the user questions. And I think that's it with the bots. Well, agents are a really important part of our society today. We can see it everywhere. It boosts customer satisfaction, makes a lot of things that in the past were really difficult, really easy right now. They can integrate with a lot of services using natural language processing. That is something that makes it like really easy to integrate, because the user doesn't have to be technical or know exactly what to say to make the user behave in the way they want it. And as AI evolves, agents are provide reliable and personalized solutions for every user. And each time it evolves, it's every time better, and it's evolving really fast right now. And well, I think that's all I wanted to share. I don't know if you guys have any question or.
Thank you so much, Nico.
Oh, wait. There's.
Thank you so much, Nico.
Oh, it's.
But mine is.
Okay, we have some. Mute your microphone.
Okay. Thank you so much, Nico, for all the introduction. I believe it was really interesting for anyone that is looking to work on a project like this. I believe he was really detailed. You were actually really good on everything you explained. You're very clear. So thank you so much for that. And guys, if you have any questions, it's your time. I believe Nico will be happy to answer you.
Hi, yes, I had a question.
Yeah.
About agents. Can you tell me what are different types of agents that are not conversational?
Yes, conversational are like the vedettes right now. I mean, they're in the spot. There's some agents like simple reflex agents. They're agents that don't mind the history or past information. They're used like I don't know, a thermostat that measures the environment temperature and triggers some heat or something like that to make the temperature of a room be in the same spot, let's say. They're used, I mean, conversational agents are used right now to answer people questions, but agents have been used in everywhere in the past years. They just have to get an input and do an action. I mean, that's all an agent needs to be an agent. Conversational agents use large language models to understand the input. So that's the difference. And there are others like model-based agents, like self-driving cars, that use a model to understand the input, like images, and they're based on past experience to drive safely, let's say. And well, another model based is the warehouse robots that based on current layout of a warehouse and move boxes from one side to another based on past experience too. So that's one kind of an agent too. There are many. Those are the most known ones.
Thank you.
Is there any other question?
Yeah, I have one. Thank you, Nico, for all the information. It was really insightful. I know there's a lot of benefits by using agents, but are there any drawbacks or problems by using that we need to consider?
Okay, yeah, there's some drawbacks or problems. There are two really known ones that are hallucination and bias. And that means the agent is trained with data, and that data can come from anywhere. If the agent can predict an answer based on your question or your prompt, it is not 100% accurate, but there can be fixed through good practices or double checking information or fetching information from a database to make the agent just based on that bit of information to answer the user question. So that can be managed. But yeah, there's some.
Thank you.
Okay, any more questions?
Yeah, sure. I have one. Previously in your presentation, you briefly covered vector databases. Can you share any real-world applications that use those types of databases?
Yes, well, they're everywhere. I think the most popular is like Netflix. Based on your movies or series you already watched, they have all their catalog vectorized and stored in a database, like the plots of the cast or in the description, and based on your previous like watch list or things you already watched, they query that database and offer you similar movies. The other is Spotify. I mean, that's the same based on genres or artists. And well, Amazon try to cross sell a lot of things based on your behavior on the webpage, based on what you have in your wish list and that kind of stuff.
Okay, is there anyone that wants to ask something else? Okay, that's it. Thank you so much to everyone who joined us. Thank you so much to Nico as well. I don't know if you have any other question or anything to say.
I don't have questions.
You don't have questions, okay. I imagine. So you want to say something?
Okay, well, I hope you enjoyed it. Anything you need, we're here. And thanks for watching.
Thank you. Bye-bye.
Bye.